Okay, I will go through one or two example, then the rest I will expect and read my PowerPoint slides. So let's say we have another scenario that we need to solve using rigid frame, plane frame. As you can see here, we have two elements here. Okay, now before you solve this question, ask yourself, do you understand where is the global axis and element axis or not? This is global axis, X and Y. And then inside each element in the question, you will see X prime with the arrow. Means that this element X prime direction in this direction is positive. For element 2, is going to the right, positive. So in test, be careful. In test, I might put something like this. Let's say this is element 3. I put X prime for element 3 going this direction, means X prime for element 3 is going to the left, positive. Okay. All right, now before we go forward, what is the angle for element 1? Brian, what is the angle for element 1? Brian, are you there?
Yes, sir.
What is the angle for element 1?
45.
45, positive or negative?
Positive.
Okay, excellent. Okay, element 2. Jia, what is the angle for element 2?
0.
0. Okay, I just add in one more element. Let's say this element have one more element, and I draw in the arrow of X prime. Is like this one. This is your element 3. If I add in this element here, or I just add in the diagram. Let's say you have one element here connecting point 1 to point 4. This is your element 3. Ashma, what is the angle of element 3?
180.
Correct. Okay, Ashma seems you understand already. Okay, good. So you understand, right? Why 180? If I add in element 3.
Yes, I understand.
Okay, good. Okay, now if you see this question, it's a combination of what you learned in chapter 4. Okay, because why? You have a distributed load here. So you need to convert distributed load, although you see the question is rigid plane frame. Before you continue solving, you need to convert distributed load to equivalent forces by using the table in Appendix D. All right, so the EAI is given. So the rest is just substitution. Okay, watch carefully on the steps. So we have two elements, point 1, point 2, point 3. Okay, before we solve, ask yourself, do you know the structure of the matrix that you expected? So if you look at the word rigid plane frame, means each point will give you 3 unknown. U1, V1, rotation 1. This is your D. What about the F? F will give you F1X, F2Y, F1Y, M1, F and D. So your K, you're going to have 3 times 3 matrix for 1 point. Okay. Oh no, sorry, not 3 times 3. K for element 1 is 6 times 6. Because element 1 connecting point 1 and point 2. Point 2 also have another U2, V2, rotation 2. And also F2X, F2 2y m2. So for the D itself, you are writing for element 1, you have U1, V1, rotation 1, U2, V2, rotation 2. So your K matrix for element 1 will be 6 times 6 matrix. Same for element 2, you have another K2. You have 6 times 6 also, because K2 connecting point 2 and point 3. Each point give you 3 unknown. So 6 times 6. And you combine K1 and K2. The capital K, you're going to get what? Ashma, what is the K matrix in this problem? What is the form or what is the structure of K matrix if you combine all the points together? What is the K matrix you have?
9 times 9.
Correct. Okay, why 9 times 9? Because you have all these, U3, V3, and rotation 3. So basically, if you write all this on the matrix itself, you write here U1 until rotation 3. You write this one, this one, this one on top of the K matrix and the side. You'll get 9 times 9 matrix. Okay, once you understand this one, it should be easy for you to solve. The first one, you need to convert the distributed load by referring Appendix D. So Appendix D is what we're familiar with. Case number 4, as you can compare this case to this diagram. So you're converting this one to F1y, M1, F2y, M2. Remember, there's a graph above this Appendix D is the equivalent free body diagram that give you something like this. Okay. So you have F2y equal to minus 2L. M2 equal to this one means this one you put in here. So you modify this one become F2y. This one also here. Okay, although in Appendix D is M1, but you put into the case that you see in the question. So this one become M2. You do the same procedure. This one will become point number 3. This one will become moment at point number 3. So this one will become M3. This one become F3y. Okay. So you substitute the value, you'll get one number. All right. And then you do the point number 3, substitute the value according to Appendix D. Here you just modify a little bit on the notation. Okay. Substitute, you get numbers. So all these is quite direct. You just substitute number. Okay. The next steps, you convert this one to this one already. As you can see, we remove the distributed load into another free body diagram from Appendix D. Okay. You can remain the diagram according to Appendix D. If you're not sure what is Appendix D, I'll open one more time for you. Appendix D is something like this. So you can copy this diagram directly from the Appendix D, and then you put in the equation. All right. So in this example, I already converted the direction, and then the magnitude become positive. Okay. So F2y, M2, and so on. Okay. All right. Remember this one, I would recommend you follow the Appendix D, the diagram, okay, that I showed you just now. Okay, I'll recommend means the direction, and then if you want to use the negative, then you follow the Appendix D diagram. This one. Okay. If you want to carry forward Okay, there's an error in my diagram. If you already converted, then mean all this value will become a positive value. Okay, just take note all this direction, follow, I'll recommend follow Appendix D. Okay, this one, you follow, then you can continue to use the negative sign that you calculate in the previous steps. Okay, take note This one, follow Appendix D. Don't follow my slides, okay? This diagram is a little bit wrong. This diagram is a bit wrong. Because the magnitude for F2y, M2, M3y, M3, I'm using the one I carry forward for the previous steps where you see negative sign here. So if you already converted the direction, it means you will always stay positive. So if you're still using the negative sign, means please follow the Appendix D diagram, this one. Okay, please follow this one. And the magnitude of this one will be negative. For example, case number 4, this point F1y here is negative. So the sign for this one is negative. Okay, so again, when you do revision, take note on this. Okay, don't follow my slides on this diagram. Okay, this diagram is incorrect because if you want to follow the direction of the diagram, this one should be positive already. Yeah, just take note on that. Okay, then after that, you put in the magnitude that you get from your calculation. Again, this diagram wrong already. This diagram should follow Appendix D direction, meaning it should be pointing up if you use a negative sign in your answer. Pointing up, the moment anti-clockwise. Okay, take note on this. All right. So element 1, 45-degree angle, you calculate the cos and sine. After you convert the distributed load to equivalent diagram from Appendix D, then you continue calculating the cos and sine for element 1, the length you can calculate. All right, this is a trigonometry question problems. So you can calculate the length by using trigonometry 45-degree. You have 30-meter length here. You can convert to this length, 1 to 2. The answer is 42.4. So you calculate the first unknown, EL equal to what value? You calculate, right? I'm not going to give you, but you just substitute the value. Then after that, you use the K matrix that we derived just now. Okay, the very big matrix. You write K matrix equal to EL. You calculate the value. After that, you assign the ticketing number for element 1. So again, when you use for rigid plane frame, the K matrix, you have U1 V1 rotation 1 and U2 V2 rotation 2. This is one set for element 1. You repeat the same for element 2 by using the equivalent diagram. Okay, so the next one is cancellation of equation. So you have 6 times 6 matrix here. However, if you look at point number 1, you start applying the boundary condition. Point 1 cannot move. So meaning this one 0, this one 0, this one 0. So you can close the matrix. Okay, you can close up. You only need to focus on this area. So you are reducing 6 equation to 3 equation. Okay. So I highlight with the box there. Then after that, you repeat the same for element 2. Element 2, angle 0, you calculate cos and sine, length is given, so you calculate E divided by L equal to what? Then you build the K matrix by using the standard equation. What is different is the location or the ticketing matrix, the ticketing location, the ticket number that you issue to all this. So for element 2, the ticket start with 0.2 and 0.3. So you have U2, V2, rotation 2, and so on. Okay, so you know that element 3 mount to the wall, so you know that this one 0, this one 0, this one 0. Again, in the test, you write U3 equal 0 equal V3 equal rotation 3 equal 0. This notation, when you write U30, V30, rotation 30, it will cost you 1 to 3 marks just to write the boundary condition out. Same with the point 1. Okay. Then after that, you close those have wall 1, you close. So you only left out with the 3 equation just now. So you combine these two matrices together. You don't need to build the 9 times 9 matrix, but because of the boundary condition at point 1 and point 3, you only need to solve 3 equations. So you combine element 1 and 2 K matrix together. Okay, K1, K2 combined, you'll get the K matrix. Then after that, you solve F equal to KD, the capital F equal to capital KD. All right, so you're going to only need to solve because 1 and 3 is mount to the wall, so you need to only solve for force at number 2. Point number 2 give you F2x, F2y, M2, and the K is 3 times 3. The displacement is U2, V2, rotation 2. Okay, so actually you are solving the 3 simultaneous equation here. So you're going to get U2. So here, K matrix, you can pull to the left-hand side. You will get inverse matrix using the online calculator. Time this one, you will get the value for U2, V2, rotation 2 straight away. Just give you some hints there. Your V2 and rotation 2 will be get a negative sign. And the value for rotation is in radian. Displacement in x direction U is in meter. Direction, displacement in y direction V is in meter. Rotation angle is in radian. Okay. So in exam, just a side note, you need to know what does it mean. Does the point move clockwise or the point rotate at the clockwise direction, or the point move up or move down? You need to know how to explain in exam. So after that, after you get the value for U2, V2, rotation 2, after you solve for the capital F, then you solve for element. So element, you use this equation, F prime equal to K prime TD. Fix already, the steps. After you solve for capital F, you continue with small f. F prime equal to K prime TD. So T standard, you just copy. T equal to this one. D equal to the one that you calculate, the displacement that you calculate. So U1 cannot move. So U1, V1, rotation 1, all 0. U2, V2, rotation 2, what you calculate just now. So you have T and D. So you use the calculator. For element 1, you have the angle already. So angle will give you the value of cos and sine. So you use your online calculator. Take this one, time this one, you get answer from the online matrix calculator. Then K matrix also standard. You press one more time inside the online calculator, you get your F prime. Okay, this is the side note for you. You take what is your T times your displacement. You get answer for the product of T and D. You get one new set. Then after that, the K prime matrix, you calculate the value inside here. Again, be careful on calculation. Always double check your products, because C1 equal to AE divided by L, C2 equal to EI divided by L cube. So these are the area where students make mistakes. They will sometimes forget the second, or the C2 here is the L power 3. And sometimes students confuse, they will put C as a cos. So be careful, it's not cos, it means something else. C1 is AE divided by L, C2 is EI divided by L cube. Just take note on that. Okay, so this K prime matrix is standard already. Okay, standard, you just need to plug in the value inside the matrix. So C1, you calculate what is it, C2, you calculate what is it, then you plug in to the matrix, then use the online tools to complete the multiplication, the triple multiplication of the matrix. All right, at the end, you will get the element force, the F prime. So again, if you are looking at rigid plane frame, your force dimension will have 3 for each point. So for point 1, you will have F1x, F1y, and moment 1. For point 2, you have F2x, F2y, and moment 2. This is only in rigid plane frame dimension, rigid plane frame chapter. Yeah. So in test, whether you know the answer, whether it is, you need to put what is that, you look at the question. Usually the question will tell you, this is the keyword, rigid plane frame. So rigid plane frame, normally you will see this one, U, V rotation for 1 point, and the F, you have F1x, F2y, F1y, and moment, this one. Okay, only happen in rigid plane frame. So after that, you repeat the same procedure for element 2. You calculate what is D, what is the T, what is the K prime, then use online calculation tools to find the for element 2. Okay, same, repeat the same. You'll get what is element 2. Again, element 2 connecting point 2 and point 3. So each point will give you, for point number 2, you have F2x, F2y, and M2. For point 3, you have F3x, F3y, and M3. Okay, you repeat the same. Then after that, you use the value to draw a free body diagram, something like this. Okay, so for element 1, you find what is your, okay, you find what is your, this is point 1, this is point 2. So each point you have F1x, F2, F1y, and your moment 1. Same with point number 2. Point number 2, you have F2y, sorry, F2x, and moment number 3. Same with this one. So here also same. For element 2, each point also have 3. 2x, 2y, and moment 2. Point 3 also same. F2, F3y, F2, F3x, F3y, and moment 3. So this one you convert accordingly to your answer. Okay, now the rest maybe I will discuss this Wednesday. Okay, I stop my lecture here. Any questions so far?